In this video, we are going to learn how to solve problems involving linear expansivity for JAMB physics. So let's get started. The first question I have here says a metal rod has a length of 100 cm at 200 degrees Celsius. At what temperature will its length be 99.4 cm if the linear expansivity of the material of the rod is 2 times 10 to the power -5 per Celsius? Okay, so basically in physics, linear expansivity can be defined as an increase in length per unit length for a degree rise in temperature. So we have the formula for linear expansivity to be L2 minus L1 over L1, L1 in bracket change in temperature. Let me use this, since we have the grid here, let me use this as change in temperature minus this, the final Celsius minus the initial Celsius. Okay, so let's get the parameters. In this question, we have our L1 to be 100 cm. We have our L2 to be 99.4 cm. All right, so we have our first Celsius to be 200 degree, okay, Celsius. We have the linear expansivity. Let me represent it with E. Linear expansivity to be 2 times 10 to the power -5 per Celsius. Okay, all right. So what we need to do now is to plug in these values in this formula we have here. So if you do it, you're going to have our L1, we have it to be, so basically, let me write it here. This is going to give us, now note that another way you can represent 2 times 10 to the power -5 is when you punch it on the calculator, this is equivalent to 0.00002, all right, equals changing length. So we have it to be 99.4 minus 100 over initial length is 100. Okay, so we don't have the final temperature. We are looking for, let's call it X minus, so the initial temperature, we have it to be 200 degrees. Okay, so when you break this down and simplify, let's bring our calculator. We use to simplify this. This is the JAMB calculator you're going to see. So you point to 0.00002 times 100. So you have the output to be 0.02. Okay, so we're going to have 0.002. Okay, X, let's call it, or let's do it this way so that you guys will not be confused. I want to simplify this thing very well for you guys. So when you cross multiply, this is the same thing as we have, let's break down what we have here. Okay, so this is same thing as 0.00002 equals, now 99.4 minus 100, we're going to have minus 0.6 over, we have 100 x minus, now 100 times 200, we're going to have 20,000. Okay, so when you cross multiply, you are going to now multiply this 0.00002 by 100x first. So when you multiply by 100x, remember we got this output. When you multiply this 0.00002 by 100, you're going to have 0.002, okay, x minus. So let's punch again let's break down this one. So we have 0.00002 times 20,000 now. Okay, now the output to be 0.4. Alright, so minus 0.4 equals minus 0.6. So you collect like terms, this minus 0.4 cross over this equality sign to change to plus. So you are left with 0.002x. This is 2 equals, let's punch this on the calculator and see what it's going to give us. We have, when it crosses over, we have minus 0.6. So let me write this way. We have minus, okay, 0.6 plus 0.4. We have the output to be minus 0.2. Okay, so I'm going to have minus 0.2. So now divide both sides by what we have here, that's 0.002. 0.002. This will cancel itself. So our final temperature will now be, you divide minus 0.2 with 0.002. So let's just punch it 0.2. Remember, we still have minus there. Okay, 0.2 divide 0.002 press equal to 500. Because of the presence of the minus at the numerator, it will not be minus 100. So the correct option in this question is option A. The final temperature will be minus 100 degrees Celsius. Alright, so that's the idea of how to solve this kind of problem under linear expansivity. Okay, so let's wipe this now and solve the next repeated question so that we understand this calculation better. Let's wipe this. Alright, so the next repeated question will be this one. It says a railroad track made of steel has a length of 55 meters when the temperature is 0 degrees Celsius. What is its length on a hot day when the temperature is 40.0 degrees Celsius? So we have the linear expansivity here to be this value. So from the formula we have already established, linear expansivity, we have it to be final length minus initial length over initial length times change in temperature. So let's represent temperature with this. Okay, so let's plug in the values. We have the linear expansivity to be this value. So we have 1.1 times 10 to the power negative 5 equals our, we are looking for the final length. Okay, so it will be L2 minus initial length is 55 over 55 in brackets. So we have 40 minus 0. So let's break this down. Alright, so when you convert 1.1 times 10 to the power negative 5 to decimal, you're going to have 0.00011. Okay, equals, we have L2 minus 55 over, now 40 minus 0 will give you 40. So basically let's punch 55 times 40 and see what it's going to give us. We have it to be 2,200. So what we have at the numerator is now 2,200. So when you cross multiply, you're going to have, let's punch this on the calculator. We have 0.00011, okay, times 2,200. So we're going to have the output to be this. So let's write it down. We have 0.0242 equals L2 minus 55. So we want to make L2 solid formula. This minus 55 crosses over the equality sign and it will change to a positive sign. So basically we are left with 0.0242 plus 55. So the output is what? 55.0242. So the correct option to this question is what? Option C. So we have it to be what? The final length L2 is 55.0242 meter. Option C. So that's it for this question. Let's wipe this now and solve the next repeated question. So the next repeated question we're going to solve will be this question. Okay, it says a metal rod whose length at 40 degrees Celsius is 15 meters is heated to 55 degrees Celsius and its length increased to 15.02 meters. Calculate the linear expansivity of the rod. So guys, before you solve this question, if you are new to our channel, ensure that you are subscribed to this channel for more of our videos. Really appreciate this. So let's go ahead and solve this particular question. It's actually very simple. From our formula, linear expansivity, final length minus initial length over, we have initial length times change in temperature. Okay, so for this question we have our final length to be 15.02 minus the initial length to be 15 over initial length, which is 15, change in temperature. So final temperature in this question we have it to be 55 minus initial temperature 40. So let's break this down. Let's simplify this with the calculator. Okay, so basically 15.02 minus 15 should give you, we have it to be 0.02. Alright, so we have equals 0.02 over, now 55 minus 40 will give you 15. So we have 15 in bracket 15. So we are going to simplify 15 times 15. That should give you 225 exactly. So our final result will now be 0.02 divided by 225. Let's check it. 0.02 divide 225. So what's the output? We have it to be this value. Okay, so guys, this is the same thing as the output we have here is the same thing as 8.8. If you want to leave it to two decimal places, it's something like 8.89 times 10 to the power -5. Okay, so that will be the answer to this question. So the correct option to this question is option D. Alright, we have our Kelvin. So that will be for this question. Let's wipe this now, solve the next repeated question. Alright, so let's wipe this. The last repeated question we're going to solve will be this question. It says, on a fairly cool rainy day when the temperature is 20 degrees Celsius, the length of a steel railroad track is 20 cm. What will be its length on a hot, dry day when the temperature is 40 degrees Celsius? Alright, so basically we are looking for L2. Okay, so from the formula for linear expansivity, we have it to be L2 minus L1 over L1 change in temperature. So I have this. So in this expression, the linear expansivity, we have it to be 11 times 10 to the power -6 equals, we are looking for L2 minus, for L1 is 20 cm over, so 20 in brackets, our final temperature is 40 minus our initial temperature is 20. Okay, so let's break this down. Okay, so another way you can express 11 times 10 to the power negative 6. If you are putting it in decimal, this is the same thing as 0.0000, okay, 11 equals, or L2 unknown minus 20 over, now 40 minus 20 will give you 20. So 20 times 20 will give you 400. So when you cross multiply, you're going to have, let's punch this now on the calculator. So you're going to have 0.0000011 times 400. We have the output to be this. So let's write this down. We have the output to be 0.0044 equals L2 minus 20. So you make L2 this solid formula. This minus 20 will cross over the equality sign and it will change to plus 20. So our final result will be, when you punch 20 plus 0.0044. So we have the output to be 20.0044 to be the answer. The correct option to this question is option D. So that will be the answer to this question, 20.0044 meter, option D. Let's go to the video, guys. Hope you learned something interesting from the video. If you are new to our channel once more, ensure that you are subscribed to this channel for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific question to ask regarding what I have talked about or solved in this video, feel free to leave your question in the comment section below and I'll ensure to give you a response. Also ensure that you are part of our channel membership by clicking on the join button to be part of the community there. In our channel membership, we share special information to those that are part of the community that helps to simplify their academic work. So ensure that you are part of it and be glad you did. Now click on the end screen above and I see you in the next video. Thanks for watching.